preserving service for genomic medicine consisting in the computation of a phylogenetic tree. This service was tested in the Madrid quantum network, being the access to the quantum resources performed remotely from 3 different locations. One location was from here, the IT Aveiro, another from the headquarters of the CDX Genomics, and the other one was from Spain, from the Polytechnic University of Madrid campus. This privacy-preserving genomic medicine service is based on a quantum-secure multi-party computation application. This quantum-secure multi-party computation application uses oblivious keys, which are instantiations of random OTs. These oblivious keys are distillations from raw keys obtained from quantum communication systems installed on the Madrid quantum network. As it is well known, it is impossible to obtain unconditionally secure quantum OT, but it is possible using quantum technology to obtain OT only with one-way functions, which was what we did. Indeed, we developed an hybrid protocol based on quantum raw keys. This allows us to avoid the use of trapdoor one-way functions, which would be required if we do not want to use quantum technology. Therefore, by using quantum technology, we could obtain a solution that is believed to be robust even against a quantum computer attack without compromising its efficiency.
We did an experiment in which the objective was to securely compute a phylogenetic tree using DNA sequences from 3 different parties. We were trying to simulate a scenario in which 3 different labs have some DNA sequence which they want to compare against DNA sequences from other labs, using for that a phylogenetic tree. So, we created a setup to validate this experiment. The setup we had involved 3 machines which were placed on different locations, one in IT Aveiro, one in Polytechnic University of Madrid, and one in CBR Genomics. These machines extracted raw and symmetric keys from true random key generators, and then proceeded to use raw keys to compute oblivious keys. This way, all the machines could transfer data and do oblivious transfers securely. These machines were set up on the same VLAN, using for that a VPN, as they aren't physically close to each other, so that they can easily communicate. To do the experiment synchronously, we made a video call with members of IT, University of Madrid, and CBR Genomics. During this experiment, each of the participants acted like a laboratory that want to do a secure multi-party computation, and so introduce the DNA sequences they want to be included in the phylogenetic tree, and thus the computation began. During this computation, the distance between sequences was computed one by one, using for that oblivious transfers. After waiting for the computation to finish, each of the participants were presented with a phylogenetic tree in which they could see how all the DNA sequences, both theirs and the other participants, were related to each other and do comparisons. This experiment and computation allowed us to validate the use case and ensure that our system was functioning properly and could be used in a real scenario. The phylogenetic tree that was computed was done so securely and privately, meaning that at no point in the computation could a participant have access to the raw sequences of another participant.